I'm Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. Today, we are going to discuss sugar, in particular, how our nervous system regulates our sugar intake and our seeking of sugar. We are going to place sugar into its proper context. The way I want to start off by doing that is to tell you a little bit of what happens when we eat and a little bit of what the brain does to respond to those events. So what happens when we eat? Let's just take what I call top contour view of the hormonal response to ingesting food. Anytime we eat, that is the consequence of a number of things that happened before we ate. There's a hormone in our brain and body called ghrelin, spelled G-H-R-E-L-I-N. Ghrelin is a hormone that increases depending on how long it's been since we ate last. Okay, so the longer it's been since we had a meal, ghrelin levels are going to be higher and higher and higher. And it essentially makes us hungry by interacting with particular neurons in an area of the brain called the arcuate nucleus of the hypothalamus, and some other areas as well, like the lateral hypothalamus. And then when we eat, typically what happens is ghrelin levels go down. So it's a very logical system. Now, when we eat, assuming that we eat carbohydrates, but even if we just eat some protein and some fats, we will experience a slight, or in some cases, a large rise in blood glucose. Blood glucose is simply blood sugar, and the body and brain, we should say, in particular, the nervous system doesn't function well if blood sugar is too high or too low. So as a consequence, we have another hormone which is released from the pancreas, which is called insulin, which helps regulate the amount of glucose in the bloodstream. Now, one of the chief organs for glucose utilization is the brain. Neurons are tremendously metabolically active, and their preferred mode of metabolism is glucose metabolism. The same thing is also true for the neurons in your body. The way that you are able to move the limbs of your body, the way that you are able to perform exercise or movement of any kind for that matter, is because neurons called motor neurons send electrical potentials to the muscle fibers. Those neurons are also very metabolically demanding, especially when you're doing demanding types of physical work, but also deliberate thought. Deliberately controlling the way that your brain and body is moving requires more glucose uptake, more energy in those very neurons. And this is also why after doing a long bout of exercise, you might be tired, but also if you do a bout of skill learning of any kind, or if you've been reading and thinking about what you're reading, or if you had an intense conversation with somebody where you're really forcing yourself to listen, that's work. And that work requires glucose uptake by neurons both in the brain and in your body. Now that we've established that glucose is the preferred source of fuel for the nervous system, I'd like to concentrate on a few of the other types of sugars that we ingest on a common basis and the impact that those have on brain function and body function. I'd particularly like to focus on fructose. Fructose, of course, is found in fruit. It's also found in the infamous high fructose corn syrup, which we will talk about today. It's worth pointing out that the concentrations of fructose in fruit is quite low compared to the concentrations of fructose in high fructose corn syrup. Typically, the amount of fructose, I think is the proper pronunciation that people are always correcting me, fructose, is anywhere from 1% to about 10%. Now, high fructose corn syrup is a different issue. And too much consumption of anything, but fructose included, can be a problem for the ways that it impacts the neural circuits that process sugar. Not just glucose, but fructose. One of the key distinctions between glucose and fructose is that fructose most likely cannot directly access the brain. It actually needs to be converted into glucose in the liver. And the way that conversion occurs feeds back to a set of hormones and neural pathways that we talked about earlier, which have a lot to do with appetite. And to just summarize what is now a lot of very solid data, fructose, and specifically fructose, has the ability to reduce certain hormones and peptides in our body whose main job is to suppress ghrelin. So although and I think pretty much everyone out there, save for a few individuals, agrees that calories in, calories out is the fundamental principle of weight loss, weight maintenance, or weight gain, ingesting fructose shifts our hormone system and as a consequence, our neural pathways within our brain, the hypothalamus, to be hungrier regardless of how many calories we've eaten. So current recommendations for most people are to eat more fruits and vegetables. But for those of you that are trying to control your hunger, ingesting a lot of fructose is probably not going to be a good idea. Certainly, ingesting it from high fructose corn syrup is not going to be a good idea because of the enormous percentages of fructose in high fructose corn syrup, 50% or sometimes even more. Fructose provides a bridge for us between a particular kind of sugar, hormone function, in this case ghrelin, and the hypothalamus, which leads us to the next question, which is, what is it about sugar that makes it such an attractive thing for us? Why do we like it so much? And the obvious answer that most people arrive at is, well, it just tastes really, really good. But that's actually not the way it works. The rewarding properties, as we say, of sugar, whether or not they come in the form of sucrose or fructose or foods that increase glucose to a very high level, actually is not just related to the taste of the foods that produce that elevation in glucose, sucrose, or fructose. It is in part, but that's only part of the story. And the rest of the story, once you understand it, can actually place you in a position to much better control your sugar intake of all kinds, but also your food intake in ways that can allow you to make much better choices about the foods you ingest. So now I want to take us on a journey into the nervous system to explain the pathways in the brain and body that regulate our appetite for sugar. Now, keep in mind what I already told you before, which is that when we ingest foods, they're broken down into various components, and glucose is going to be shuttled to the brain and, of course, to other neurons in our spinal cord and elsewhere, and to our muscles, et cetera, in order for all of those cells and organs and tissues to be able to function. The fact that so many cells and organs and tissues require glucose in order to function has led to a situation where you have dedicated neural machinery, pieces of your brain that are almost entirely, if not entirely, devoted to seeking out of sugar or foods that contain sugars, and to make sure that you not only seek those out, but you know where those foods are and that you ingest more and more and more of them. And there are two main ways that these neural circuits work. In fact, we can say that there are two neural circuits entirely that work in parallel. In the case of sugar consumption, the two parallel pathways involve one pathway related to the actual taste and the perception of sweet tastes that lead not just you, but every animal that we're aware of to seek more sweet-containing foods. The other parallel pathway is related to the nutritive component of sweet foods, meaning the degree to which a given food will raise blood glucose. I want to repeat that. One pathway in your brain and body is devoted to getting you to seek out sweet-tasting things that you perceive as sweet, and another parallel pathway is devoted to getting you to seek out foods that lead to increases in blood glucose. It just so happens that the foods that lead to big increases in blood glucose typically are associated with that sweet taste. Now, this is distinctly different than the neural pathways that control seeking of savory foods or salty foods or spicy foods for that matter, or bitter foods. The sweet pathway is what we would call hardwired. It exists, as far as we know, in every mammal. Basically, getting sweet stuff into the body might seem like it has a lot to do with the taste, but it has just as much to do with the nutritive components that sweet-tasting foods carry, and the fact that your nervous system and so many cells in your brain and body run on glucose. If you recall earlier, I said even if you ingest fructose can be converted into glucose in the liver. The fundamental thing to understand here is that when you think you want a piece of chocolate, or you think you want a piece of cake, or you're craving something sweet, you are both craving the taste and your neurons are literally craving the nutritive components that arrive with that taste. Okay, two parallel pathways. One of the parallel pathways has to do with conscious perception. So when you ingest something sweet, very quickly there are signals sent from those neurons in your mouth to brain areas that cause you to seek out, or at least pay attention to, the source and the abundance of those sweet things. They literally change your perception. Does that mean that you should never ingest anything sweet? No. Certainly, I'm not saying that. Everyone has to decide for themselves what the appropriate amount of sugar intake is. But I find it remarkable when people say, oh, I need to get my sugar fix, or I need to have my chocolate, or I need to have a little bit of something to just kind of take care of that sugar appetite. Because in taking care of that sugar appetite, maybe for the very disciplined of you, you can just have that one piece of chocolate and it's great and you can relish in it. But it does shift the way that you perceive other foods as well. And the way it does that is through our, probably, if you're a listener to this podcast, now old friend, but incredible neuromodulator, dopamine. Dopamine is a molecule that is released from several places in the brain. There's a so-called mesolimbic reward pathway, which is a whole set of places in the brain or circuits designed to get us motivated and craving and in pursuit of things. And then, of course, there are areas of the brain that are involved in movement that are linked up with those areas involved in motivation. That makes perfect sense. Why would you have a brain area involved in motivation if you couldn't actually do something with that motivation? When we ingest something sweet, the perception of that sweet taste increases dopamine in the mesolimbic reward pathways, which then are conveyed to pathways for motor behavior and in general place us into modes of focused action toward getting more of whatever was sweet. But if you understand the way that dopamine works, what you'll realize is that when this dopamine pathway is triggered, it tends to create not the sensation or the perception of satiety, of feeling like something is enough, but rather to produce the sensation of wanting more. In fact, we can say that the longer it's been since you've indulged in something that you really enjoy or would like, the greater the dopamine you will experience when you finally engage in that behavior or indulge that thing, ingest that thing. Now, I'm not saying that you shouldn't pursue pleasurable things. These dopamine pathways are not evil, they're not bad, but once you understand the way they work, you can leverage them to your advantage as opposed to them leveraging you to their advantage. Now, there's the second pathway. The second pathway is what's called the post-ingestive reinforcing properties of sugar, which is really just a fancy nerd speak way of saying there are events that happen within your stomach and below your conscious detection that are also driving you to seek out sweet tasting things independent of their taste and foods that increase blood glucose independent of their taste. And here's how it works. We all have neurons within our gut. These neurons have a name. They are called neuropod cells. Neuropod cells were famously discovered by Professor Dr. Diego Bojorquez at Duke University. And these cells respond to, among other things, to the presence of sugar within the gut. These neuropod cells send electrical signals through a particular highway within the vagus to the so-called nodose ganglion. This is a cluster. A ganglion is just a cluster of neurons. And then the nodose ganglion sends on information to the nucleus of the solitary tract. The nucleus of the solitary tract is very important for understanding sugar preference. So we've all heard of hidden sugars, meaning the sugars that manufacturers have put into foods and disguised them with other flavors. The savory foods are often laden with these hidden sugars that we can't register as sweetness, but trigger the neuropod cells, which then further trigger dopamine, which make us want more of them. Now, we may be able to resist eating more of them, but it makes us crave more food in general. Now, we will talk about ways to regulate this pathway, to sort of intervene in this subconscious pathway. But for now, I'm hoping that just the understanding that we all have this pathway, this is hardwired into our body, could potentially allow people to better understand why is it that their cravings are so intense, that it's not necessarily just about the taste of that food. And when you consider this, you start to realize that there are multiple mechanisms hardwired into us that make it especially hard to not eat the sweet thing or to not eat the food that we're craving. And indeed, that's the case. We have two major accelerators. It's like a car with two accelerators, and we will talk about the brakes, but two ways that really get us into forward motion toward pursuing the consumption of sweet foods. Now, some of you have probably heard of the so-called glycemic index, which is basically a measurement of how high and to some extent how fast blood sugar rises in response to ingesting particular foods. And very broadly speaking, we can say that there are low glycemic index foods of less than 55, it typically is the measurement, or medium glycemic index foods, which go from about 55 to 69, and then so-called high glycemic foods, which are above 70. And of course, there's additional nuance related to glycemic load and many more features of the glycemic index. A couple of things to understand about how the glycemic index is measured, and then I'd like to just briefly talk about how the glycemic index can be leveraged to short circuit some of the neural circuits that would otherwise lead us to crave and perhaps even ingest sugary foods. First of all, measurements of glycemic indices of food are typically made by having people ingest those foods in isolation. And in general, we can say that anytime we ingest fiber and or fat, lipids, along with a particular food, it will reduce the glycemic index of that particular food, either the absolute level of blood glucose that a particular food causes or the rate at which that elevation in blood glucose occurs. Okay? And this is why there are some seemingly paradoxical aspects to sweet stuff in terms of the glycemic index. For instance, ice cream has a lower glycemic index provided it's ice cream that includes fat, which I hope it would because that's the good tasting ice cream in my opinion, compared to something like mangoes or table sugar. The glycemic index is not something to hold holy in most cases because most people are not ingesting foods in isolation. Now, why am I telling you about the glycemic index? Well, if we zoom out and take our perspective on all of this discussion about the glycemic index through the lens of the nervous system, and we remind ourselves that neurons prefer glucose for energy and that all sweet things or things that we perceive as sweet, but also sweet things that are ingested and registered by those neuropod cells in our gut, trigger the release of dopamine and trigger these neural circuits to make us want to eat more of these foods. What we start to realize is that a sharp rise in blood glucose or a very high degree of elevation in blood glucose is going to be a much more potent signal than will a more moderate rise in blood glucose or a slower rise in blood glucose. And so for those of you that are trying to reduce sugar intake and you want to do that through an understanding of how these neural circuits work, and you want to short circuit some of the dopamine release that's caused by ingesting sugary foods, it can be advantageous to ingest sweet foods in combination with foods that reduce glycemic index or reduce glycemic load. So that might mean making different food choices. So paying attention to sweet tasting foods that can satisfy sugar cravings but do not have as steep, or I should say do not cause as steep a rise in blood sugar. Or it could mean consuming other foods along with sweet foods in order to reduce the glycemic index and thereby slow or blunt the release of dopamine. So if you really wanted to adjust your sugar cravings and you really still want to ingest some sugary foods, you probably would be better off combining fiber with that sugary or sweet food. So what we're really talking about here is trying to reduce the dopamine signal that is the consequence of ingesting sweet foods. And we're talking about doing that through these different parallel pathways, not just by preventing sweet taste, but also by preventing the post-ingestive effects of sweet foods. And of course, the backdrop to all of this is that most of us, again, most of us, not all of us, should probably be ingesting fewer refined sugars. So what are some ways that we can reduce our sugar cravings? And ideally, ways that we can do that also benefit us in other ways, both nutritionally and from the neuroscience standpoint. The fact that these neuropod cells and, I should say, other neurons within the gut respond very robustly to the presence of particular amino acids is also a potential lever by which one could reduce sugar cravings. And there's an interesting literature around the amino acid glutamine, in particular supplementing with the amino acid glutamine as it relates to sugar cravings and certainly as it relates to other aspects of the gut, in particular leaky gut. The use of supplemental glutamine to try and treat leaky gut is not a new phenomenon. There are other approaches too, of course, but there are many people who are experimenting with supplementing with glutamine several grams per day, often even 5 grams distributed through 3 or 4 different servings throughout the day as a way to blunt their sugar cravings. Now, there has not yet been a large-scale clinical trial using glutamine to reduce sugar cravings, but the results of the few studies that I looked at, as well as my understanding of the logic of these neural circuits, including the neuropod cells, brings us to a conclusion that it makes sense why, if there's a population of neurons within our gut that responds very robustly to the presence of sugar, fatty acids, or amino acids, that the intake of particular amino acids would allow the dopamine pathways that might otherwise be triggered by sugar to be triggered by something like glutamine, which has very few or no calories. I know some people who actually take glutamine and mix it with full-fat cream and take it kind of like a shot of full-fat cream, which sounds absolutely delicious, by the way. Glutamine is a little bit chalky, so it's not that great tasting to ingest with sugar. I should mention that if you do try and take this approach of ingesting glutamine to reduce sugar cravings, you want to increase the amount of glutamine that you take somewhat gradually. It can create some gastric distress if you just, I certainly wouldn't take a big tablespoon of it, throw it in water and chug it down 3 times a day. Please also realize that there's an entire literature devoted to the potential hazards of increasing glutamine if you have a pre-existing cancer. So if you have cancer or you're cancer prone, I would really discourage you from this approach. And in any case, as always, talk to your doctor. Now, there are other ways to reduce sugar craving, and there are certainly ways to reduce the sharp rise in blood glucose that can occur when we ingest sugary sweet foods or even just an abundance of carbohydrate foods. And there are a huge number of these things. I'm going to sort of layer up through the ones that you might find in your cupboard at the grocery store and then get into some of the more extravagant, or I should say esoteric ones, many of which, however, can be quite potent. The first of which is simple lemon juice, right, or lime juice. Regardless, there are now data pointing to the fact that lemon juice and lime juice, a couple tablespoons or so, if ingested before or even during or even after consumption of sugary foods, or I should say foods that sharply increase blood glucose, or large carbohydrate meals, can actually blunt the blood glucose response. And I did see that when I did my own experiments on myself with continuous glucose monitor. It was kind of fun to do those experiments. I preferred to do those experiments by eating somewhat larger meals of things that didn't contain a lot of sugar. I saw some big increases in blood glucose in certain instances, and then I would ingest some lemon juice or lime juice, typically mixed in with water. And sure enough, you could see a blunting of the blood glucose response. And of course, this was real-time, continuous, hence continuous blood glucose monitoring. When you ingest lemon juice or lime juice, the mechanism by which it blunts blood glucose is probably twofold. One is probably through the post-ingestive effects of glucose in the gut, meaning the way in which sugars are interacting with neurons and other components of your gut circuitry to impact things like gastric emptying time, to impact things like the firing of those neuropod cells and their signaling to the brain. But almost certainly it has something to do also with the perception of sour taste on the tongue. We didn't go into this too much today, but you, of course, don't just have sweet taste receptors in your mouth. You also have bitter taste receptors. You have salty taste receptors. You have sour taste receptors in your mouth and on your, and of course, that means your tongue and palate. And those are interacting. If you ingest a substance that's just sweet or mostly sweet, that causes a certain set of effects on your blood glucose, but also your brain, dopamine, and the other neural circuits of your brain. If you also ingest something that's sour, like lemon juice or lime juice, it adjusts the output of those neural circuits in your brain. So again, we have a situation where we have two parallel pathways, one that's post-ingestive coming from phenomenon within our gut, neurons, but also things like gastric emptying time, the clearance and the transfer of food and the conversion of food into particular nutrients and the circulation of glucose in your bloodstream and how it gets into the brain. But also simply by ingesting something sour, you are changing the way that sweet things impact your brain. And so I think it stands to reason that the lemon juice, lime juice effect is not going to be magic. It's going to have everything to do with the way that ingesting sour foods can adjust the neural response to taste of sweet foods. And in fact, we know based on the beautiful work of Charles Zucker at Columbia Medical School that that's exactly what happens. Now, some of you have probably heard that cinnamon can be a useful tool for controlling blood sugar. And indeed, that's the case. It's very clear that cinnamon can adjust the rate of glucose entry into the bloodstream, possibly by changing the rate of gastric emptying. It might slow the rate of gastric emptying and thereby also reduce the glycemic index of particular foods. So I suppose if I were going to eat a mango and I hadn't just done a bunch of hard training, I might sprinkle some cinnamon on it. Here, I always enjoy kind of coming up with new ideas of ways that I can eat foods during these podcasts. I do want to provide a cautionary note about cinnamon, however. Cinnamon contains something called coumadin, which can be toxic at high levels. So you don't want to ingest more than about a teaspoon, maybe a teaspoon and a half of cinnamon per day, because you'll start to exceed the threshold at which cinnamon could start to be problematic. So we've talked about lemon juice and lime juice and cinnamon. These are kind of commonplace in many kitchens. Then, of course, we can venture into the more esoteric, or I would say the more advanced tools for adjusting sugar intake. The one that comes to mind is, of course, berberine. Using berberine is a serious step. You should absolutely talk to your doctor about it. It is true that if you ingest berberine, your blood glucose will plummet. And I point that out because I've actually tried it before. It gave me brutal headaches, and I felt really dizzy, and I felt like I couldn't see straight. And actually, I couldn't see straight. Why did it do that? Well, it made me hypoglycemic. It actually drove my blood glucose down too far. And the reason it did that is that I took berberine on an empty stomach. If I took berberine along with a very large meal that included a lot of carbohydrates, then I felt perfectly fine on even up to 750 milligrams or a gram of berberine. But again, talk to your doctor. I would place berberine and, of course, metformin and glibenclamide in the kind of the heavy-hitting, potent tools for regulating blood glucose. And there are some other substances like sodium cuprate, which are known to augment the effects of berberine via the AMPK pathways. They basically can increase the ability for berberine to have its glucose-lowering actions. But that, of course, is getting into the really potent, what I would call sharp blade tools for controlling blood glucose. And listen, anytime you're dealing with blood glucose, you are dealing with the brain's preferred source of fuel. And anytime you're dealing with the brain's preferred source of fuel, you have to be especially cautious about depriving the brain of what it needs. These substances like berberine are very, very potent, and you need to take them seriously. There is yet another tool for controlling sugar cravings and the neural circuits that regulate sugar craving and its downstream consequences. And this tool is what I would call a high-performance tool, but it's one that you probably didn't suspect, and that's sleep. I've done extensive episodes about sleep. We actually have an episode called Master Your Sleep. You can find that episode easily at hubermanlab.com. It's available in all the various formats, YouTube, Apple, Spotify, etc. And provides a lot of tools, and on social media, I provide a lot of tools. What is the role of sleep in sugar metabolism, sugar hunger, and the way that the brain regulates those things? Well, there's a really exciting study that came out just last year. This study was published in the journal Cell Report, Cell Press Journal, excellent journal. The reason I love this study so much is it involved having people, so yes, this was done in humans, sleep in the laboratory. That's not unusual. There's a sleep lab at Stanford. There's sleep labs elsewhere. What they did was they actually measured from the breath of these people, and they extracted from their breath the metabolites that would allow them to understand what sorts of metabolism was occurring in these people's bodies at different phases of sleep. They actually did this every 10 seconds throughout the entire night. What they discovered was that each stage of sleep was associated with a very particular signature pattern of metabolism. And particular phases of sleep are associated with sugar metabolism, or more with fat metabolism, or more with other aspects of metabolism. And the reason why I think this study is important to discuss in the context of today's discussion about sugar in the brain is that many people have experienced the effects of disrupted sleep on their appetite. And in particular, it's been reported that when people are sleep deprived or the quality of their sleep is disrupted, their appetite for sugary foods increases. Now, we don't want to leap too far from this study to sugar metabolism and the neural circuits controlling sugar metabolism. But I will say this. There is now a plethora of data pointing to the fact that getting quality sleep each night helps regulate not only appetite, but also the specific forms of metabolism that drive specific appetites. So we can't overstate the importance of getting regular, sufficient amount of high-quality sleep, at least 80% of the time, not just for sake of immune system function, for clear thinking, etc., but also for properly regulating our metabolism, including our sugar metabolism. Thank you for joining me for this discussion about sugar and the nervous system and how they are regulating each other in both the brain and body. And last but certainly not least, thank you for your interest in science.